Alright, what's up everyone? Next lecture is going to be a quick little lecture about forces and specifically friction. We already went over like forces in free body diagrams, how there's like arrows in all different ways. And now a specific force that's a little bit more interesting is the force of friction, which is only applied when you have a force in a certain direction already going. So say we have an object here, mass m, sure, and it's being applied a force of like 2 newtons, say. Friction is always going to be a force that's going to go in the opposite direction of what way it's moving, but this force is only going to be present if the object is actually like accelerating. And if the object is like not accelerating, then there's no force actually acting on it in a way that would accelerate it. We call this force due to friction. And so the way we find force due to friction is based on the normal force, which is how much this ground is exerting on the mass n, which makes sense because that's how much is pushing up. It's how much like contact there is rubbing together, which is the cause for all this friction. So the proportion between normal force and the actual force of friction is what we call mu, which is a Greek letter which just represents the ratio of the force of friction to the normal force. And in the majority of the time, we're talking about mu kinetic, which basically means the force of friction when it's moving. And mu static just refers to like how difficult it is to start moving, which it's not actually acting upon the force unless you like try to initiate the movement. So most of the time we're talking about kinetic mu, which is when we're already moving and it's how much force is trying to stop it from moving. And so yeah, basically force of friction equals normal force times mu. And normal force sometimes is mg, doesn't always have to be mg, it could be mg sine theta, mg cosine theta, something like that. But yeah. All right, problem 13. A skier is traveling down a slope which is 30 degrees above the horizontal. And it's told that the coefficient of friction between the skier and the slope is 0.1, and it asks to find the acceleration of the skier as he goes down. To give him some skis. Okay, so we know acceleration is force times mass. Force is mass times acceleration, so we can find acceleration by calculating the forces and dividing it by the mass. We know that the forces acting upon the skier causing it to accelerate are the gravitational component, which you go straight down, is mg, and the horizontal, this looks a little too slanted, that's mg, and we can split it up into that, which is mg sine of 30, and this, which is mg cosine of 30. And the cosine cancels out with the normal force, we don't really need to worry about that. But he has a downward force of mg sine 30, or we can replace sine 30 with 1/2 mg over 2. And so the upward force in this case is friction. Force of friction equals mu times normal force. And in this case, the normal force, I drew it here, I just erased it, is mg cosine of 30. And mu is 0.1. So force of friction equals mg cosine 30 over 10, which is also equal to mg root 3 over 20, which is the force going up. So the net force on the skier is mg over 2 minus mg times root 3 over 20. And of course, to find the acceleration, we just divide by the mass to get acceleration. And we have a equals g over 2 minus root 3 over 20 g. And substituting g equals 10, and calculating root 3 over 20, we get a is about 4.2 meters per second squared, which is answer choice B.